This conference will now be recorded.
Hey, hi, welcome everyone. So this is Vamshi Krishna here. So I'll be your training for big data or data engineering. So this training is totally driven towards 45 hours, and we will try to get started with the agenda. Just give me 1 minute, guys. I'm bringing a call. Just give me 1 minute. Hey guys, sorry for the interruption. Yeah. So this training is totally for 45 hours. First, we'll try to understand the agenda for today's session, and then we will try to go as per this agenda, right? Uh, so first, let me just try to come up with the agenda. So I already have it in place. So this is going to be our agenda, and we will go step by step and try to understand as per this agenda, right? So first, let's try to understand what will be the first step. So first, we'll try to understand why Hadoop is in huge demand, and we'll talk about what is big data, what are the sources of big data. Then we will talk about the categories and then characteristics of big data. Then we'll make a comparison between the traditional RDBMS and then Hadoop. Then we'll take one level deeper. Then we'll try to understand what is Hadoop and then the history of Hadoop. Then we're going to talk about the architecture of Hadoop and then the core components that are involved in Hadoop. Then we will see how to set up Hadoop on our laptop so that we will start with the hands-on sessions right from day one. So this is going to be our agenda for today. So let's get started as per this agenda. So first, let's try to understand why big data, Hadoop, and data engineering, they are in huge demand. So you can clearly see that the Forbes claims that by 2022, we could see the Hadoop market crossing. So let me just highlight that. So Forbes claims that by 2022 we could see the Hadoop market crossing $99.31 billion. In fact, the PayScale.com claims that the salaries of Hadoop professionals would vary around $93K to $127K. In fact, even IDC claims that by 2024 we could see the big data market crossing $210 billion. These are some of the staggering numbers because of which we can clearly say that the salaries of Hadoop professionals would be at least around $112,000, which is 95% greater than the salaries of all the other job postings. And also, you can clearly compare Hadoop with other technologies. So that's a leading technology in the market right now, right? So there are a lot of openings, and you can also understand that the reason for the big data and data engineering is very, very high now, because the reason is there is shortage of skilled professionals in the industry right now. So basically, you are learning the right technology at the right time. And also, there are a lot of unfilled jobs yet to be filled in the big data world. So the trend and demand for big data is going to continue in the coming years as well, right? So this is with respect to how big data on data engineering is doing in the market right now. So let's get into the technical details. So first, let's try to understand the sources of big data. Now, when I say sources of big data, it is nothing but, first, where is this big data coming from, right? Where is this big data coming from? So right now we're in 2022. We are talking about, the sources of big data. That is, where is this big data coming from? So we know that 1 minute is nothing but 60 seconds. So within a span of 60 seconds, there are a lot of things happening all over the world. If you take Facebook, Facebook claims that 973,000 logins are being happening, and Google claims that 3.7 billion queries are being searched, and even WhatsApp claims that 38 million messages are being transferred. Again, remember that all this is happening within a span of just 60 seconds of time, just 1 minute of time. There are a lot of things happening all over the world. Even Instagram claims that there are a lot of posts that are being made on Instagram, and many apps are being downloaded from Play Stores and App Stores. Even YouTube claims that 4.3 million videos are being watched. These are some of the staggering numbers, because of which we can clearly say that the big data is going to grow in the coming years as well, continuously. So let's talk about the formal definition of big data. What is big data? It is fairly simple to guess the definition of big data. So big data is actually nothing but the huge amount of the data. Now the data is so huge that it cannot be stored in the traditional RDBMS such as MySQL, Oracle, etc. because the data is so huge. And I have an interesting statistic for you. 90% of the data that's available on the earth right now, it has been generated in the past few years. And remember guys, as a big data developer or as a data engineer, we will have to talk with multiple teams on daily basis. And all the talk typically happens in terms of data. Now, we know that the data is measured in bits and bytes. So this memory capacity conversion chart is going to form as a foundation for your big data journey. So let's try to understand this step by step. So 1 byte is nothing but 8 bits, and 1 KB is nothing but 1024 bytes, and 1 MB is nothing but 1024 KB, and 1 GB is nothing but 1024 MB, and 1 TB is nothing but 1024 GB. Now the real question is, when can we say that we have got the big data problem? So if the data generation is crossing the limits of terabytes, right? If the data generation is happening in terms of petabytes or exabytes or zettabytes or yottabytes, that's where we typically call it as a big data problem, right? I hope now we are clear with what a big data problem is. So having understood the definition of big data, let us try to understand the categories of big data. There are 3 categories of big data. Let me try to highlight the same. So we have got structured data, unstructured data, and then semi-structured data. So let's go one by one. So first, let's try to understand about the structured data. So what is structured data? As the name suggests, we'll have a proper structure here. So if you take the data that is stored in the databases, how will the data in databases will look like? The data in databases will be stored in the form of tables, right? So horizontal ones is nothing but the rows, vertical ones is nothing but the columns, right? So we have got the structured data such as tables. So table is an example for the structured data. And coming to the second category, unstructured data. So unstructured data is nothing but the data which doesn't have any structure at all, right? So I want to give some examples for the unstructured data. So I see that everywhere CC cams are being installed these days, be it houses or offices, wherever you go, you will find CC cams. So what do these CC cams generate? The CC cams generate huge amount of the videos, right? So videos is an example for the unstructured data. And if you have the habit of listening to FM, what do these FM generate? The FM generate huge amount of the audio, right? So audio is also another example for the unstructured data. And as a part of daily communication in offices, we typically use mail, right? So mail is also another example for the unstructured data. And coming to the third category, semi-structured data. Now, as the name suggests, the semi-structured data would fall in between the structured and unstructured data. Couple of examples for the semi-structured data could be the XML data. So XML basically stands for extensible markup language. And another example for the semi-structured data could be the JSON data. So JSON basically stands for JavaScript Object Notation. JavaScript Object Notation. Again, guys, so these two terms you may not be able to understand for now, but we will deal with these with respect to the hands-on in the coming sessions. So that's where it will make more sense to you. So in a nutshell, there are three categories of big data: structured data, unstructured data, and then semi-structured data. Now we are very clear with the categories of big data. Let's talk about the characteristics of big data. So the characteristics of big data is also called as 3 V's of big data. So the first V is nothing but the variety. So variety refers to the different forms of the data. Again, the data could be anything. So it could be text data or sensor data or documents, images, audio, or video. So variety refers to the different forms of the data. Coming to the second V, velocity. Velocity is nothing but the speed at which the data is being generated. Now let me take an example here. So I see that everyone is using social messaging apps these days, such as Facebook, WhatsApp, Twitter, Instagram. So everybody have the habit of posting something onto these social messaging apps. So some post it on minute basis, some post it on hourly basis, some post it on daily basis, and some post it on weekly basis. Somehow or the other form, directly or indirectly, everybody is generating huge amount of the data. So velocity refers to the speed at which the data is being generated. Coming to the third V, volume. So volume refers to the quantity or size of the data. Again, the data that is getting generated might be in the megabytes or gigabytes or terabytes or petabytes. So volume refers to the quantity or size of the data. If all these 3 V's happen together, that's where we call it as big data problem. Now we are very clear with what a big data problem is. We are very clear with the characteristics or 3 V's of big data. Now let me ask you one inter question here. Let me ask you one inter question here. So typically, a lot of people have a misconception that big data and Hadoop are same, but are they really same? This is one of the inter question. What is the difference between big data and Hadoop? What is the difference between big data and Hadoop? So a lot of people think that they are same, but there is one small difference between these two. So big data is nothing but the problem that we have got, and for every problem in this universe, there must be a solution, isn't it? Now the solution to deal with big data problem is nothing but Hadoop. So in a nutshell, big data is the problem that we have got, and Hadoop is a solution to deal with the big data problem. So now I hope we are clear with the differences between these two. Now you must be still wondering, okay, when we already have the traditional RDBMSs such as MySQL, Oracle, etc., then why do we need something called as Hadoop? That's a very valid question and very important question from the interview perspective as well, right? So let's try to do that comparison by considering these 6 points. So let's go step by step. First, let's try to understand the storage limit. In the traditional RDBMSs, we have certain storage limit constraints. That is, beyond certain limits of data, you won't be able to store your data. So that's the biggest disadvantage in the traditional RDBMSs. Whereas on the other side, Hadoop is very flexible because you can store as much data as you want in Hadoop. There is no storage limit constraint at all. Coming to the second point, varieties. In the traditional RDBMSs, we can store only the structured data in the form of tables. We cannot store the unstructured or semi-structured data in traditional RDBMSs. Coming to the other side, Hadoop can actually be used to store structured, unstructured, as well as semi-structured data. All types of data can be stored in Hadoop. Coming to the third point, the cost of the software. So let me give an example here. Suppose, let's say that I'm working on some traditional RDBM system. I would typically have to first buy the license software, right? I have to pay a huge amount of money to buy the license software. Not only that, you need to renew the license of the software every few years. Only then you can work on it. So there is a lot of money involved both to buy the software as well as to maintain it, right? So that is going to actually increase the cost of your project. But whereas on the other side, Hadoop is completely free. You don't need to pay any money to anybody to start using Hadoop. So as it is absolutely free, and of course that's going to decrease the cost of your project. Coming to the fourth point, processing type. So let me give an example here. Suppose, let us say that I'm dealing with the data from all the citizens from all over the world. So it includes the details from all the countries in the world, such as US, UK, China, Japan, India, etc. Now my goal is to get the citizens who belong to US. So that's my goal. Get me all the citizens who belongs to US. So that's my problem statement, or that's my requirement. Now how will this query look like? Select star from citizens table where location is equal to US. So this query is going to start from the first record. It's going to check whether that record contains the location field as US or not. That's going to continue until the last record, right? So this is going to take a step-by-step approach right from the first record till the last record of the table. But there are two problems here. The first problem is, first of all, we cannot store such huge data because the data is huge. We cannot even store it. Even if we somehow store it, this query will take at least 4 or 5 days of time to get you the results. But as an end user, do we really have 4 or 5 days of time to wait and see the results? No, right? Everybody wants quicker results these days. That's where the traditional RDBMSs fail to satisfy the requirements of the end user because they are really slow, because they work in a serial or sequential fashion. On the other side, Hadoop is very smart because we are not going to store the data on a single computer in Hadoop. We are going to store the data across multiple computers in Hadoop. We call it as distributed storage. And on those respective machines, the data processing happens. We call it as distributed processing. Again, we'll talk about that in depth in the same session. But for now, just to summarize about the fourth point, the processing type, the traditional RDBMSs work in a serial or sequential fashion, which will have a lot of performance impacts. On the other side, Hadoop works in a distributed or parallel processing model, which will give you very good performance. Coming to the fifth point, cost of the hardware. So generally in the traditional RDBM system, if you wanted to handle the client queries, you have to have the high-end servers. Again, to buy the high-end servers, we need to pay a huge amount of money, right? So because the high-end servers requires high-end hardware as well. So that's again going to increase the cost of your project. On the other side, in Hadoop, we don't need a high-end server. Even with the help of the commodity hardware as well, we should be able to build our Hadoop clusters. Now, what is commodity hardware? So commodity hardware is nothing but the non-expensive hardware. So even with the help of the non-expensive hardware as well, we can easily build our Hadoop clusters. So as we are talking about non-expensive hardware, the cost of the project will be less. And the last and important point, source code. So generally in the traditional RDBM system, let's say for some reason I'm facing some stability issues. But what are the options that you're left with? I don't think you have any other option. All you need to do is to wait until the next version of that particular software comes into the market, right? Even if it is working very slow, you will have to wait until the next version comes into the market. But on the other side, Hadoop is absolutely free, right? And also it is completely open source. Now, when I say Hadoop is open source, it is nothing but the source code is absolutely free, and you can download the source code, you can play with it, you can customize it, and you can modify it as per your need. So out of the comparison of all the 6 important points, I can clearly say that Hadoop is a clear winner over the traditional RDBMS, right? In fact, this is one of the very important interview question, guys. If you get this question, you should be able to explain this by considering 2 to 3 points. That should be more than enough in the interviews, right? So now let us talk about the history of Hadoop, how Hadoop came into the world. So Doug Cutting is the founder of Hadoop technology. So we know that Google is a very popular search engine now, but way back in 2003, Google was facing a severe problem. Google was unable to store all the queries that were searched by their users on their search engine. That's where in 2003, Google was looking for a solution. Now the solution came in the same year in 2003 in the form of a white paper called as GFS. GFS stands for Google File System. So this is a solution for the storage problem. So basically, this is the place where all the big data is stored, right? And it eventually span into another white paper in 2004 called as MapReduce. So MapReduce is the data processing layer. That is, whatever big data that is stored on Google File System can be processed with the help of MapReduce. And Doug Cutting's son's toy elephant name is called Hadoop. So that's the reason why you would see a small elephant everywhere we talk about this term called as Hadoop. So now we are clear with the history of Hadoop. Let's talk about what is Hadoop. As I told, Hadoop is an open source project. Hadoop is an open source project coming from the Apache Software Foundation. And many people have a misconception that Hadoop is a programming language. No, Hadoop is not the programming language. Hadoop is a software framework that is meant for the distributed storage and the distributed processing model on the cluster of servers. Now, what is a cluster? Cluster is nothing but a group of computers that are connected together. And in fact, Hadoop took the inspiration from Google File System as well as from the MapReduce programming model to come into the market. So when Hadoop started, Hadoop was not the main project. Hadoop was the sub-project of Nudge. So there used to be a project called as Nudge. So Hadoop was the sub-project of Nudge search engine project. But gradually Hadoop gained the popularity. So Doug Cutting moved from Google to Yahoo. So Hadoop became completely open source. So Hadoop is completely open source and it's built in Java as a programming language. So this second point is important. So Hadoop efficiently processes the large volumes of the data on cluster of commodity hardware. So let's try to decode this statement. So here we're talking about cluster, which is nothing but group of computers that are made up of the commodity hardware, that is the non-expensive hardware. So Hadoop can be set up on a single machine. So today I will walk you through the detailed steps about how to set up Hadoop on your laptop. But the real power of Hadoop comes with the cluster of machines. Again, guys, so just to tell you, so as we progress through our training, so we are going to build 3 live projects and we are going to create multi-node clusters on Amazon Web Services and we are going to deploy our project there. So again, if you have this skill set of Big Data, Hadoop and Spark with AWS Cloud, that's a very hot skill in the market right now, right? So we'll talk about that in the coming sessions. So coming back here, before going further, I have a simple and interesting story for you. So there lived a king in a kingdom. One fine day he wanted to find out how many people are living in the kingdom. That's where king called his minister to figure out the number of people living in the kingdom. Minister just obeyed king's order. He said that he is going to figure out the number of people living in the kingdom. And minister went alone to figure out the number of people living in the kingdom. Remember one important point, guys. Minister went alone to figure out the number of people living in the kingdom. And of course, as he went alone, he took a lot of time to figure out the number of people living in the kingdom. So king is not happy because even though he's getting to know the count of the people living in the kingdom, minister took a lot of time. So that's why king is not happy. So that's why king also suggested to minister to take help from other soldiers as well while going for the count next time. Now for the next time, minister took the help from other soldiers and he finished the given task within a short period of time. And king is also absolutely happy because the reason is he's getting to know the count of people living in the kingdom within a short period of time. If you closely compare the first approach where minister went alone to figure out the number of people living in the kingdom, it is nothing but the sequential or serial processing model on which the traditional RDBMS are based upon. They are really slow because they work in a serial or sequential fashion. Now, coming to the second approach where minister took help from other soldiers as well, it can be compared with the distributed or parallel processing model because we have multiple people here and they are going to take care about counting the people, right? So that's how even Hadoop is no different. Hadoop is very close to the same concept because even in Hadoop also we have got something called as master, which can be compared with the king, and we have got bunch of slaves which can be compared with the soldiers, and of course we do have the secondary master, which is nothing but the minister. So Hadoop architecture is based upon the master slave architecture. That is, whatever king orders, soldiers are going to do it for the king. It is something similar to that. Whatever master orders, slaves are going to do it for the king. And also, the data on Hadoop systems are always stored across multiple computers. Data is stored across multiple computers, hence it is called a distributed storage. And this entire block diagram is called as Hadoop cluster. This entire block diagram is called as Hadoop cluster. So in a nutshell, I would say that the Hadoop architecture is based upon the master-slave architecture. So now there are certain technical terms given to these. Let's try to understand what those technical terms are. So master is nothing but the name node, NN in short. Secondary master is called as secondary name node, SNN. Slaves are called as data nodes, DN, or worker nodes, WM. So these technical terms are really important. Let me repeat it again. So master is called as name node, NN. Secondary master is called as secondary name node, SNN. Slaves are called as data nodes, DN, or worker nodes, WM. So I'm going to use these technical terms going forward. So there are two core components in Hadoop, such as HDFS and then MapReduce. What is HDFS? HDFS stands for Hadoop Distributed File System. So this is basically the storage layer in Hadoop. Now when I say storage layer, this is the place where all the big data is stored. And coming to the MapReduce, so MapReduce is the data processing layer. MapReduce is the data processing layer. So whatever big data is stored on Hadoop Distributed File System, all that can be processed with the help of MapReduce. So in a nutshell, Hadoop is always a combination of two core components put together, such as HDFS and then MapReduce. Now let us try to understand more about each of these core components. First, let's talk about HDFS. What is HDFS? HDFS stands for Hadoop Distributed File System. Now, why is it called a distributed file system? Because always the data is stored across multiple computers. And also, another point to be noted is whenever we deal with data in Hadoop, we will always be dealing with the multiple copies of the data. Also, one of the inter question here is, in Hadoop, where is the data stored? In Hadoop, always the data is stored on the data nodes or the worker nodes. Remember that point. That is one of the inter question. Always the data is stored on the data nodes or worker nodes in the cluster in Hadoop. So let's say that the scenario is this. Let's say that I have a huge file, basically a big data file. So this huge file has been broken down into small parts. Each small part is called as block. Let me repeat that again. I have a huge file, basically a big data file. I'm going to break that huge file, or I'm going to split that huge file into small parts. Each small part is called as block. So where are these blocks stored? Always the blocks are stored across data nodes. and that too, every block is available in multiple copies. Now you must be wondering, so why are we talking about multiple data nodes and multiple copies of each block? So there is a very good reason behind that. I'll cover that shortly. But for now, always remember that the huge file has been broken into small parts. Each small part is called as block. These blocks are stored across multiple data nodes, and that too, every block is available in multiple copies. There are two versions of Hadoop available right now: Hadoop version 1.x, Hadoop version 2.x. In Hadoop version 1.x, the default block size is 64 MB. In Hadoop version 2.x, the default block size is 128 MB. So to make this block concept clear, let us perform a live task. So this is the data from one of the organization. So this organization contains the details about all the employees: employee ID, employee name, and employee location. The size of this file is 260 MB. The size of this file is 260 MB. Now we need to figure out how many blocks can be created from this file. So the first question that you should ask is, which version of Hadoop are you using? Imagine that we are using Hadoop version 2.x. So in Hadoop version 2.x, the default block size is 128 MB. So I'm going to divide 260 by 128. So what is 260 here? 260 is nothing but my file size. 128 MB is nothing but my block size, default block size in Hadoop version 2.x. So how much will this be? 260 by 128. It's going to be 2 point something. Right? 260 by 128 is 2 point something. 2 point something. So it's very clear that I'll have two full blocks. That is, I'll have block 1, a full capacity of the block, which is nothing but 128 MB. And I'll have block 2, again a full capacity of 128 MB. Right? Now, how much will this be if you add 128 plus 128? It will be 256. But how much is my file size? It is nothing but 260 MB. So 260 MB minus 256 MB, that will be 4 MB. So I'll have a third block of size 4 MB. So to answer my question, totally there will be 3 blocks. 2 blocks will be of size 128 MB, and third block will be of size 4 MB. Right? So that's the answer to my question. So now we are very clear with the block creation concept in Hadoop. So let us talk about fault tolerance. Why BIGDATA on data engineering is very popular? Because of fault tolerance capability. Let us talk about what the fault tolerance capability is. So let's say that I have a large file, basically a BIGDATA file. I'm going to break up this large file into small parts. So each small part is called as block. You can see that I have block 1, block 2, block 3, and block 4. So where are these blocks stored? As I have told, all these blocks are always stored on the slave machines in the cluster. Also, I have told that every block is available in multiple copies. That is, I have block 2 first copy here, I have block 2 second copy here, I have block 3 first copy here, I have block 3 second copy here, I have block 4 first copy here, I have block 4 second copy here. Now to process this large file, I need all the 4 blocks: block 1, block 2, block 3, and block 4. But one day, the slave machine on which this block V1 is there has gone down. It's not working. Do you think we still be able to process this large file? Yes, we can, because we have got other copy of block B1 which is available on other slave machine which is working fine, right? So this ability to tolerate the faults, because even though one of the slave machine has gone down, there is no impact on the business, there is no downtime, because it's going to make use of another copy of the block which is available on the other worker machine. So this ability to tolerate the faults is called as fault tolerance capability. And this is the reason why BIGDATA and data engineering is very, very popular, because of this fault tolerance capability. And in fact, this is also one of the interview question, right? So the reason behind maintaining multiple copies of each block is to provide the fault tolerance capability. So that's with respect to HDFS. Let's talk about MapReduce. So MapReduce is other core component in Hadoop. So MapReduce is the data processing layer. The way it works is, it's going to take the work, it's going to break the given work into small tasks, and all those tasks could be executed independently. So let us understand this better. So let's say that I wrote this MapReduce program MR, and I'm going to give this MapReduce program MR to the master machine. So this MapReduce program is given to the master machine. Again, remember, master is the master, because master machine has got complete idea about where the data is stored. Now what master is going to do is, the master is going to copy the same MapReduce program only onto the machines wherever the data is available. Remember an important point, it's not going to copy into every machine. The master machine is going to copy the same MapReduce program only onto the machines wherever the data is available. And on those respective machines, the actual data processing happens. And finally, the results are sent from the each worker machine or each slave machine onto the master machine. Right? So that's how the data processing happens in MapReduce. So let us put everything together, how Hadoop works. So there are totally 4 steps. I would say that step 1 and 2 belongs to HDFS, step 3 and 4 belongs to MapReduce. In step 1, I have got my input data, basically my big data. I'm going to break it up into small parts. Each small part is called as block. Block size can be 64 MB if you are using Hadoop version 1.x. Block size can be 128 MB if you are using Hadoop version 2.x. Now in step 2, where are these blocks are stored? Always the blocks are stored across the different data nodes or worker machines in the cluster. And in step 3, we are going to write the MapReduce program that will take care about processing the data. And finally, in step 4, the results are sent back to the master machine. So that's how Hadoop works with these 4 steps. Now I wanted to introduce to another important concept called as Hadoop Daemons. But before that, what is a daemon? What is a daemon? So a daemon is nothing but a continuously running process. So suppose, let me give an example. Suppose, let's say that you switch on your laptop and there is something called as task manager. On your laptop, there is something called a task manager that starts running as soon as you switch on your laptop, and it will keep on running until you shut down your laptop. So the task manager is an example for the daemon process. Task manager is an example for the daemon process. So similarly, there are total 5 daemons in Hadoop, 3 in HDFS, 2 in MapReduce. In HDFS, the master daemon is nothing but the name node, and the slave daemon is nothing but the data node. Of course, we do have the other daemon in the form of secondary name node. Coming to the MapReduce, the master is nothing but the job tracker, and the slave is nothing but the task tracker. Let us put it in a different way. So we have the storage layer in Hadoop, which is nothing but the HDFS, and we have the MapReduce layer. In the storage layer, that is in HDFS, name node is going to act as a master, and bunch of data nodes, they're going to act as slaves. And coming to the MapReduce, the job tracker is going to act as a master, and bunch of task trackers, they are going to act as the slaves. Now the question is, how do these daemons communicate among themselves in the real-time projects? So in the real-time projects, we'll have something called as master machine, and we'll have something called as slave machines. On the master machine, the job tracker and name node daemon will be running together. On the slave machines, we'll have the task tracker daemon and data node daemon running together. So the job tracker will be in touch with all the task trackers, and the name node will be in touch with all the data nodes. So that's how the communication among these daemons happens in the real-time projects. Right? So that's with respect to the Hadoop daemons. Now let me ask you one interview question, guys. This is a very popular interview question, and it is expected in every interview. So which Hadoop flavor are you using, or which Hadoop distribution are you using? This is a very popular interview question, and it is asked in every interview. So first, let's try to understand what is a flavor or what is a distribution. Let me give a simple example. Suppose, let's say that someone is using Samsung smartphone. So what is the mobile operating system in Samsung smartphone? It is nothing but Android. Let's say if someone is using iPhone, what is the mobile operating system in iPhone? It's nothing but iOS. So what are these? These are nothing but the flavors or distributions in mobile operating systems such as Android and iOS. So similarly in Hadoop also we have different flavors and distributions. They are nothing but Cloudera, Hortonworks, and then Mapper. So today I will walk you through the detailed steps about how to set up Cloudera distribution of Hadoop on your laptop. So to set up Hadoop on a laptop with the Cloudera, we need to use something called as Cloudera Quick Start VM. So first of all, what is a VM? VM stands for virtual machine. Now what is a virtual machine? So virtual machine is like a virtual computer. That is, what does your laptop have got? Your laptop have got hard disk to store the data, CPU for the processing capability, and RAM for the main memory purpose. So similarly, the virtual laptop or the virtual computer or your virtual machine also would require all those three: CPU, hard disk, and then the RAM. You must be still wondering, okay, I would require the Cloudera Quick Start VM. Then why would I need something called as VirtualBox? Let me answer that question. Suppose let's say that you wanted to listen to an audio song. What is the format of audio song? Generally, the audio song format would be MP3 format, right? Now, to listen to this audio song, we would typically require a player such as VLC media player or Windows media player. So some sort of player is definitely required to actually listen to this audio song. So similarly, to use this Cloudera Quick Start VM also, we would require some virtualization software. So that virtualization software is nothing but VirtualBox, right? I hope now we are clear with how these two are related. So now let me walk you through the detailed steps about how to download and how to install each of these. So first, let's see how to download VirtualBox. It's very simple. You just have to go to Google, say download VirtualBox, and then click on this first link. And once you click here, it will take you to this page. And here, it depends on your operating system. So you may be using Windows, you may be using Mac. So in my case, I'm using Windows. I'm going to click on Windows host. Suppose if you're,
Can you share the link?
yeah, I will share the link. Don't worry. See,
Yeah.
I will show this live. I will show this live about how to download, how to install this. But for now, I'm just giving you some simple overview.
Okay,
I'm going to show this live, so don't worry about that.
Yeah. Thank you.
So I was talking about the operating systems here. Suppose let's say that if you're using Windows, then you have to click on Windows source. If you're using Mac, then you have to click on OS X source. That will download the VirtualBox for you. And once the VirtualBox is downloaded, it's very simple to install it. To install it, you just have to double click on it. Then this will be the first screen. You just have to click on next. And then this will be installed in your C drive. So that should be fine. But if you wanted to select a different location, click on browse, select a different location, and then you can click on next. So then it's going to create some desktop shortcuts from me. That should be fine. Leave it as it is. Don't disturb that. Click on next. And proceed with the installation now. Yes, you just have to click on yes. That will start the installation of the VirtualBox. You just have to click on install button. That will start the installation of the VirtualBox. It's very simple and very easy to download and install VirtualBox. You can do this in 5 minutes of time. It's very easy. And once you click on finish, that will finish the installation of VirtualBox. It's very easy to do that. Again, guys, don't worry. I'm going to share all these slides with you once the session is done, so that you can refer to these slides and you can set up Hadoop on your laptop. Basically, the Cloudera Quick Start VM on your laptop. So don't worry about that. So now we are clear with the downloading and installing of the VirtualBox. What about Cloudera Quick Start VM? So the Cloudera Quick Start VM is not available on the internet anymore. It is available with me. I have a copy of the Cloudera Quick Start VM in my Google Drive. I'm going to share this Cloudera Quick Start VM with you. So if you guys can share your email ID in the chat box, I'm going to share this Cloudera Quick Start VM with you once the session is done, because that is not available on the internet anymore. So if you share your email ID in the chat box, I will share this with you once the session is done. So now then we have to download this, right? So it's very simple to download this. So I will show this live in our next session. So once you download this, so this is how it will look like. So you have to extract it because that's a zipped folder. So that's a zipped file, you have to extract it. So right click on it, say extract to, and that will actually create this folder structure for you. You will see these two files, right? So what have we done till now? We have seen how to download and how to install the VirtualBox. Also, we have seen how to download and how to extract the Cloudera Quick Start VM. It's the time to open this Cloudera Quick Start VM by using the VirtualBox. So I'm going to open my VirtualBox and click on File here, click on Import Appliance. And then I'm going to click on this yellow color icon, and then I'm going to go to the place where I have that Cloudera Quick Start VM downloaded and extracted. I will select that file and then I'll click on Open. Then I'm going to click on Next. So this screen is very important, guys. So CPU and RAM. So I will show this live in our next session how to set up these. So for now, don't worry about these. So you have to give these details and then click on Import button. After a couple of minutes, it will show something like this. Then you have to click on Start and then click on Normal Start. So that's going to start your Cloudera Quick Start VM, right? So this is how it will look like. After a couple of minutes of time, the Cloudera Quick Start VM should look something like this. So this is the place where we're going to do our hands-on, right? And suppose, let's say you are done with the work for the day, you can power it off. You can go to your VirtualBox, click on that, right click on it, close, power off. That should take you to the powered off mode. So that's how we're going to set up the Cloudera Quick Start VM on our laptop. Again, guys, don't worry because I'm going to show this live in our next session, right? So that's where, everything will be a lot more clear. So now let me try to summarize what we learned today. So in today's session, we have basically learned that big data is nothing but the huge amount of the data. Now the data is so huge that it cannot be stored or processed by the traditional RDBMS such as MySQL or Oracle. Also, we have learned that big data is a combination of 3 V's put together, such as volume, variety, and then velocity. Also, we have learned that big data is the problem that we got, and Hadoop is a solution to deal with the big data problem. Also, we have learned that Hadoop is a combination of 2 core components put together, HDFS and then MapReduce. Also, we have seen that there are 2 versions of Hadoop available right now, Hadoop version 1.x, Hadoop version 2.x. In Hadoop version 1.x, the default block size is 64 MB. In Hadoop version 2.x, the default block size is 128 MB. Right? Also, we have learned that there are totally 5 daemons in Hadoop, 3 daemons in HDFS, 2 daemons in MapReduce. In HDFS, the master is going to be the name node, and the slave is going to be nothing but your data node or the worker node. Of course, we do have other daemon in the form of secondary name node. Coming to the MapReduce, the master is nothing but the job tracker, and the slave is nothing but the task tracker. Right? And guys, based on today's session, I have got 10 interview questions for you. Right? So what I would suggest is, I will share this recording with you. You can go through the recording one more time and come back to these interview questions and try to answer these questions on your own. Of course, I'll be providing the answers to these questions in a separate file so that you can cross check. Right? So if the training goes for 30 to 35 days, then I'll be sharing 10 interview questions on daily basis along with answers, and 5 assignments along with answers on daily basis. So that will roughly come up to 300 plus different interview questions along with answers and 100 plus assignments along with answers. So with that, you should be in a position to be employable in the big data world. So what can you expect at the end of this course? So I can guarantee that you should be in a position to become employable in the big data and Hadoop world. That is for sure, because this is going to be a pure hands-on oriented training, completely practical oriented training. And we are going to work on multiple POCs. POC stands for proof of concepts. And we'll be dealing with 3 live projects at the end of the training. So these 3 live projects you can showcase in your resume and you can start your job search. And What is the specialty of this training? As I told, this is going to be pure hands-on oriented training, and it will equally expect from you to practice on daily basis as well, right? And what can you expect from me at the end of the session each and every day? You're going to get the recording of the session that's covered, PPT that's covered in the session, and 10 interview questions along with answers, and 5 assignments along with answers. As I told, if the training goes for 30 to 35 days, we will be dealing with at least 300 plus different interview questions along with answers, and 100 plus assignments along with answers. Along with that, I'll be sharing 20 real-time interview recordings. Let me repeat that. I'll be sharing 20 real-time interview recordings because those were the real-time interviews recorded by my old students when they were giving the interviews. So they'll be definitely helping you out when you start your job search, because all those 20 real-time recordings are recorded by my students when they were giving the interviews. I will share all those recordings with you at the end of our training. Also, I'll be conducting mock interviews. I'll give you some tips and tricks about how to answer the questions in the interviews. Right? So I think pretty much this is what I want to cover, guys. So anybody have any questions, you can put your question in the chat box. Anybody have any questions so far?
With the recording, is it possible that you forward us the PPT just in case?
Yeah, sure. I'll upload the PPT as well. You'll get
Okay.
PPT, you'll get the recordings, you'll get the interview questions along with answers and assignments also. Every day you're going to get all these.
Can I be expecting to get, like, because I don't have any other contact information except for the app this meeting.
Sorry, repeat the question again.
Just where can I be expecting all these the recordings and the PPT folder?
I'll upload it in other than half an hour or so.
Okay. The thing is, I don't have any other contact available from.
Okay.
Yeah,
Okay, guys. So see, I'll be sharing my contact in the chat box.
Oh.
So yeah, so you can get in touch with me for any queries. 1 minute, I'll just paste my WhatsApp number in the chat. Just give me a minute.
I think we have any group in the WhatsApp, right?
No, we haven't have any group right now, but let's see. But meanwhile, I would require 2 things from each one of you. One is your Gmail ID, because that's where I'm going to share the Cloudera Quick Start VM, all the training recordings, all the training content. So I would require your Gmail ID. Along with that, I would require your WhatsApp number as well, because all the updates related to the classes will come to your WhatsApp. Basically, the timings, meeting links, everything will come to your WhatsApp. Also, if you want to quickly discuss something with me, let's say you are practicing something and you are seeing an error. If you want to quickly share that with me, that will also help you to get your doubt resolved quickly. So I would require 2 things from each one of you. One is your Gmail ID, the other one is your WhatsApp number. So I hope everyone have given their Gmail ID. So I would require your WhatsApp number also in the chat box.
Okay. All right.
Yeah. So the training will be from Monday to Friday, guys. So most likely at the same time, whenever so whatever time that you are connecting right now, the same timing will be there. Again, guys, so I hope you guys have given 2 things. One is your Gmail ID and one is your
Okay.
one is your WhatsApp number. Yeah.
Can I do one? Can you share? Can you create the group and share the link so everyone can join in the WhatsApp group? Then maybe that will be.
See, Kiran, actually, because of some privacy issues, I cannot create a group. But don't worry about you can actually get in touch with me for any of the queries, right? Okay. Because of privacy issues, I could not create a group. So share your WhatsApp number in the chat, so I'll get in touch with you personally.
Okay, that's good.
Yeah.
And actually, you want to say something like, what we are like, everyone here from non-technical background, so we are not.
See, irrespective of the background, whether you are coming from technical, non-technical, whatever may be the technology, this course is driven towards making you from beginner to expert. But only commitment that I would require from you is to practice on daily basis. That's the only commitment that I would require. Rest of the things I can take care.
Okay, I will do that one.
Sure. Okay, guys, I think everyone have given their email IDs as well as WhatsApp numbers. I'll get in touch with each one of you personally. Okay. So again, we will start with our actual training sessions from Monday onwards, right? So the assignment for this week is going to be go through the recording again and see if you can set up the Cloudera Quick Start VM. You can give a try. Even if you cannot do it, don't worry, because I'm going to show that live on Monday, right? So our next session or actual sessions will start from Monday onwards. Same time, a meeting link I'll keep you posted on your WhatsApp number if you have shared your WhatsApp number. Okay. Any other questions, guys? Anybody have any other questions? Okay, then I think we are good so far. I think then let's meet on Monday. Then same time, I will share the meeting with you on your WhatsApp numbers, and I'll also share this recording with you on your Gmail IDs. Okay. So I will also get in touch with each one of you personally on your WhatsApp number, either tomorrow or after tomorrow. Yeah. So see you on Monday, guys.
All right. Thank you so much.
Bye, bro.